Again, if I were going to factor these problems, I'd really be looking at the rational root theorem and looking for candidate rational roots that may, in fact, produce a zero in the problem. And looking at it, it's the factors of 3 are just 1 and 3. Then the factors of 6, which are going to be 1, 2, 3, and 6. Now, granted, it's a list. I don't think I'd want to go through every single possibility, but I start making stabs at it. And I want to tell you the first one that you should arrive upon is A equals minus 1. In other words, when you plug in A equals minus 1 over here, you get a 0. So what does that mean? That means I get a factor of A plus 1. Now, by the way, if I do the division, I get a cubic, and I realize cubics are also difficult to deal with. Let me repeat this. You're allowed to use calculators, so you could actually do this quite quickly on a calculator, all right? What I mean by that, testing out the rational roots. The next rational root you're going to stumble on, and I mean you stumble on it, is going to be 1/3. Now, what does that mean? It means 3a is equal to 1, or 3a minus 1 equals 0, which means it's a factor of the problem. Then what do? You take this, you multiply it out, and you divide it into this, and you get a quadratic. And the quadratic you should get if you do the division is 2a squared minus a plus 3. All right, let me repeat this. Rational root theorem, trial roots, see what one works. These two work nicely. And then a long division to get the remaining quadratic. That remaining quadratic, you could try it. It really doesn't make much sense trying things like this, but I'll put this one down for you. Yeah, 3 and 1. That's about the only possibility to come up with. But unfortunately, I can't get a sign that would do that for me. It's just not going to happen. All right, so I'm going to say using fingers, that's just not going to happen. Let me erase this over here. Let me erase this notation over here. And I got to say that it's work to get it, for me anyway. I get this. Now, my claim about this one over here, once you do this, you're basically assuming that this guy also has factors. And what's nice about this is it's still the rational root theorem. Plus or minus. What do you get over there? The factors of 9 would be 1, 3, and 9. And then what do you get? I'll take a look at it. On the bottom, you get 1, 2, 4, and 8. And certainly, the first one I could probably stumble on is A equals, let's see, looking at that, looks like 1, all right? So if you did that, well, you get a factor. And this is more difficult, there's no doubt about it. And what factor would you get? The factor A minus 1. Now, by the way, I'd want to look for another one, and it's not easy, but I'd look for the other one, and I'm going to say the A minus 3/4. Now, granted, it takes effort to get that. There's no doubt about it. It's arithmetic, by the way. Now, someone says, oh, I'm going to do it by long division. You could, by finding arithmetic easier than long division. So what does that mean? 4a equals 3. 4a minus 3 equals 0. And then I get a factor over here, 4a minus 3. Now, I know what you're thinking. You're not getting what you want. And that's true. You're not getting what you want. What are you getting? You're getting this factor, nothing to do with the other one, and this factor, nothing to do with the other one. Now, what do you have to do? You have to do long division. And you're going to take this, expand it, and divide it into that. And if you do that, you should get this over here. And yes, this one's a lot of work to get through. What do I now know? I'm seeing that these two, when factored, have something in common. What do they have in common? Just this thing, a quadratic. It's right over here, all right? These are more difficult problems, no doubt about it. Thank you.